This is probably important for, I would smoke that. But I do.
Push problem find the volume of the solid result of the region close by the curves revolve around the x-axis. Okay.
Okay.
So this does not require you to graph this. It would be helpful though. So just real quick, if we did graph this, y equals x squared. Terrible problem, but that's fine. X equals 1, y equals 0. So it's just this little area right here that's being rotated around the x-axis. So this means we are definitely doing the washer method, not the washer method, the this method, because there's no hole in the graph. So in this case, it's just what? Pi times the integral of 0 to 1 for x of x squared dx. So pi times the integral from 0 to 1 of x to the fourth dx. That gives you pi times 1/5 x to the fifth from 0 to 1, which would just be 1/5 pi, or pi over 5. Now you want to write the decimal, 0.628, if you want the decimal one. I don't care which one you do.
Why?
Because it's circular. So basically, remember it's pi r squared times the height. The radius is the function. What's the height? The bounds.
Yeah.
The bounds give you the height. So the radius is the function itself. So pi r squared gives you pi times the function squared. The bounds gives you the height.
How do we know when you use water?
If we have a hole in between, okay? And basically that's why graphing it would probably help. So here, each problem results around, in this case, the axis is y equals 1. All right, so graphing this, we have negative x squared plus 2, so starting at plus 2, negative x squared. All right, y equals 1, so this line right here. And we're rotating around y equals 1, so this is the line of rotation as well.
Notice it's positive.
It's positive.
Yes, we.
Where's the negative at? Okay. All right, so this area is being rotated around this line, giving us this. So again, this is another disk method. All right. So pi times the integral from 0 to 1 of the function squared, so negative x squared plus 2 squared dx.
2.
Neither. It's actually neither. I have this entirely wrong because what did I not graph? The other side. So it would be from negative 1 to 1, because that's also being rotated around. Negative 1 to 1. Yeah. So negative 1 to 1. Now, if you want to do this, this gives you integral from, well, you can do, since it is a even function, you can do 2 pi from 0 to 1.
Why did you not graph the other side of the thing?
Because the bounds told us not to.
Because it was the y equals 0, the
Y equals 0 is the, is it y equals 0? Yeah. Oh yeah, y equals 0. Because that gives us this line right here. Where do they intersect? Here to here. So yeah. Good question though. If you square this, you are going to get x to the fourth minus 4x squared plus 4 dx, which gives you 2 pi times 1/5 x to the fifth minus 4/3 x to the third plus 4x from 0 to 1. You can, since it's a even function, it's the same area from the left and right of the axis. So you can just double this area to get that. So now, plug in 0 just gives you 0, plug in 1 gives me 2 pi times 1/5 minus 4/3 plus 4. So that'd be out of 15. So 3/15 minus times 5, 20 over 15 plus 60 over 15.
We need a rule of 0 to 1, and you should definitely get leading function to it's the same on both sides. So like, it's from -1 to 1, you just take in your parts from -0 to 0. Usually doing half the integral, putting in just that way. You can do it either way. You can either get rid of the 2, but do it maybe 1 to 1. Half to 0 to 0 1 later.
Not getting the same answer they got.
Factor in the axes and everything and that's position.
You are so correct there. Good catch. Yep. So yeah, my radius, that's not my radius. My radius is the distance of my function to the line of rotation, which would be the function minus the line of rotation. So yeah, negative x squared plus 2 minus 1 squared. Which that does become just plus 1. So we can do 2 pi times the integral 0 to 1 of that squared would be x squared minus 2x, so x to the fourth minus 2x squared plus 1 dx, which gives me 2 pi times 1/5 x to the fifth minus 2/3 x to the third plus x from 0 to 1, which would give me that, which is much better. So that gives me 2 pi times 8 over 15, which is 16 pi over 15. Or you could write that as 3.351. Now here's the thing. You can use your calculator, so feel free just to put that in your calculator, okay? You don't have to just by hand. It's just good practice if you're going to take the AP exams.
Since it's the lowercase rx, we're squaring the 1 octal. It's rx minus rx.
That's if it's that's if it's washer method. You separate the two. If it's disk, it's just one function square.
If the exam will have to do that by hand.
Some of those, yeah, you'll probably want to be able to do things by hand. Because again, you have a calculator section and a non-calculator section. So for both multiple choice and free response. Now, I believe your free response is 4 with calculator and 4 without, or 2 without. I don't know how many questions are calculator versus non-calculator on the multiple choice. I'm assuming you always have more with a calculator. Okay. All right. Next one. Here we, nicely enough, because this one's actually pretty nice, since we're rotating around the y-axis, they went ahead and put it in terms of y for you. Okay, don't expect that on the test. All right. So if you need it be in y-axis, make sure you know how to put things in terms of y. Now, one nice thing about this test is some of these questions are not going to ask you to solve. They just want you to set up the integration. That is the answer. So what would the integral be? Do not solve. So a lot of them, in fact, are like that. Because again, can you just put in a calculator if you have the integration? Yeah, that's not much of a challenge. So being able to set it up is going to be the fun part. Quite often, yeah. So that's where I get the questions from, is the AP website. All right. So number 12, we graph switch to y. Okay, we have lines x equals 0, which is the y-axis. Y equals -2 and +2. All right. Now, what is 2y plus 5 at 0? I don't know what the graph of that looks like. Let me see. I don't know if I'm going to get a good graph because it's not in terms of y. So let me. So at -2, we have that value, which is helpful. I mean, at -1, we have 4. And then at 2, we have that value. So that's what it's going to look like. Okay. So it will look like so it is this area being rotated around the y-axis. All right. So, nice thing is they kind of give us the bounds for the y. -2 to 2. All right. Of the function squared. 2 squared of y plus 5 squared dy. Don't forget pi. Now, the nice thing is what happens when you square root? Let's get so pi times integral from -2 to 2 of 4 times y plus 5 squared. You can bring the 4 out. 4 pi, do the integration of that, which would give you what? One-third of y plus 5 cubed? No, it can't be that. Can't be that, can it?
Why is 5, y plus 5 squared in the second?
Oh yeah, it's not squared. Good catch. That's what I got confused on. dy. So that just gives you what? 1/2 y squared plus 5y from -2 to 2. Plug in 2, we get 4, 2 plus 10. Plug in -2, we get the same thing, 2 minus 10. That becomes -8, so plus 8. So it becomes 4 pi times 20. 80 pi. All right. Here we have our graph. We're rotating around x equals -2 of X equals y squared minus 2. -2 and y is 1. So, oh, it's a little curved. Okay. Oh, we're rotating around this line right here. Okay, so it's this area right here getting rotated. That's easier. Okay. So what's the y bounds?
1.
0, 1. And again, since I'm rotating by a function that's below or to the left of the function, it's going to be the function minus the line of rotation. So it's going to be y squared minus 2 minus the -2 squared. Now, what happens to -2 minus a -2? It just cancels. So it gives you -2 plus 2, which is just 0. So it's y squared squared, or pi times the integral from 0 to 1 of y to the 4th. So I end up with pretty much the same answer I had before, 1/5 pi.
Don't forget the dy.
Oh yeah, dy. Don't forget that. They are stickler on that on the AP test. So. All right. 14 through 8, 17. So 4 more. Now these are going to be 2 separate functions. This is kind of how you can tell when you're going to have a washer method, is when I have 2 separate functions. So y equals 2x plus 1 starts at 1. Goes up 2 every time. So, and then y equals x squared plus 1 starts at 1. So right here at 2. So here we have 0. Both have 0, 0, and both have 2, 4. Actually, that would be 0, 1, and 2, 5. Now, because you plug in 0, you get 1. Plug in 2, you get 5 on both. So there's your intersections. All right. That means my integral, since it's rotating around the x-axis, will be from 0 to 2. Those are my x values. Now, which function is furthest from the x-axis? So 2x plus 1, get pi, squared minus x squared plus 1 squared dx. And I am not about to do that by hand. Don't want to. But again, that's the kind of question is, how would you set it up? Set it up and do not solve. Or do not evaluate. All right. But if you want to evaluate, that's what you get.
On the test, we want to confirm.
I don't think I'll care. So, yeah. Doesn't matter. Most of your test is multiple choice. Okay. You have, I think, let me see the test. All right. Go away. So, you actually have a matching section, okay, where you're given a description. You're to match the integral and the graph. So you have to pick out what's the correct integral and what's the correct graph.
Like,
We're doing here, yeah. So, and after that, you have 1, 2, 3, 4 multiple choice questions, and 1 free response that has parts A through D. Now, on the free response, the ones that require you to set up and find the volume by rotation or cross sections is to set up but do not evaluate. There's only one question where you actually have to go from beginning to end, find the volume, find the answer, set up and find the answer. Everything else is either multiple choice or find the area.
questions will be.
So 4 multiple choice, 1 free response with 4 parts to it, and then 4 matching questions. Well, actually, kind of 1 matching question, but it's got 4 parts. Yeah.
All right, wait.
So yeah,
I'm my first homework assignment. It was 2 questions.
again, make sure you look at the answers on these multiple choice questions. That'll help you know, one, like for example, could I put this in terms of y?
It really wanted to, yeah.
So look at your answers. Make sure that they are in the correct terms. Okay? Yeah. I mean, I'm trying to imitate the AP test, so yeah, mine is. Yeah.
Let's see it before.
Yeah. Yeah.
Right. I plus C. Wrong. Like, geez, anything, it could be 0. 0. Question. I love it. If they see right for everything, they should get number. No.
So here we have the function y equals negative x squared to the fourth, y equals x plus 2. So x plus 2, 1, 2. Over 1. And we have negative x squared plus 4. And we are rotating around y equals negative 1. So that would be down here. All right, so this, oh, from negative 2 to negative 1, I am forgetting that part. So just this part right here is being rotated. So I don't really need any of this. Oh, not the whole thing.
Hello.
I don't know why it all went away, but that's fun. All right. Close enough. So that's going to rotate, which means it should create this little section down here. Okay. And we're going to have a hole, all right, in this shape. All right. Why do you keep disappearing half the stuff? There we go. It just doesn't, does it? All right. Now, what function is furthest from my line of rotation? We given our bounds negative 2 to negative 1. That's easy enough. So my big function is what? Yeah, negative x squared plus 4. So negative x squared plus 4, but I have to subtract what? Subtract a negative 1. Yeah, so plus 1 squared minus, and then I have x plus 2 minus a negative 1 squared, so plus 3. Put plus 5 plus 3. That's just a mess. Let me try that again. So we had x plus 4 minus a negative 1 squared minus x plus 2 minus a negative 1 squared dx. That's going to give me pi times going from negative 2 to 1, negative 1 of negative x squared plus 5 squared minus x plus 3 squared.
Yeah.
We good? dx. Now, if you go through that, put that in your calculator, you're going to get 83 over 15 pi or 17.383. Again, that's not a bad example of what you're expected to do in the test. Is to create that. Now, again, even though it does say set up but do not evaluate, you do want to simplify. So I would be looking more for this instead of that first part. Now, putting this in terms of y. So y square root of y plus 4. So starting at 1, 2, 3, 4. It's basically 5. Right. Right, and then y over 2 plus 4. So plug in 1 for y, I get 4.5.
What are you looking at the bottom?
Plug in 2 for y, I get 5. So it should be right here at 6. So this should be 4, 0, and 6, 4. That's 6, 4. Really?
How did that's true. 93.
So it should give me 7. Should be sorry, 4, 4. Can't be 4, 4. It's 4, 6. That's what I had backwards. 4, 6. 6, 4. Never mind. I had it right. I'm just doing it in my head backwards. So yeah, we're good. And so what are my bounds? What are my bounds? This is where they intersect. So what are my y values?
40.
That's not a 10, that's a 0. 0 to 4. All right.
Wow.
Now we are rotating around the y-axis this time, so the furthest from the y-axis is square root of y plus 4 squared minus, minus y over 2 plus 4 squared dy. Don't forget the pi. Now, there's no way to simplify that, so that's just going to give you 40 over 3 pi, or 41.888. Post the answer key, right? I think I did. Okay. Make sure. All right. Well, at least we have a similar graph.
Oh, of course, you know, you're saying.
Yeah.
1, 2, 3, 4, 5, 6. 2, 3, 4. So 4, 0. And we have what? 6, 4.
What do you go super one? Also 21 6.
All right, and we have y squared plus 4. Okay. So y squared plus 4 starts here. And then if I plug in 1, I get 5. Oh, okay. That's it right here. So they intersect at 4, 0 and 5, 1. Okay, so at least I know my bounds are from 0 to 1, pi. I'm rotating around x equals 2. So the graph furthest from that would be square root of y plus 4 minus 2 squared minus y squared plus 4 minus 2 squared dy. Now, you do need to simplify that to be pi times 0 from 0 to 1 of square root of y plus 2 squared minus y squared plus 2 squared dy. That's what I would expect to see for that question. And if you did solve it, 49 pi over 30, which is 5.131. There it is.
Was it pi? Was he fine with this?
Again, you don't even have to do the solving for the most part. I would probably want I will take either answer. Okay, but if you just want to put it in your calculator, put it in your calculator.
Okay.
Yeah. So if you leave in terms of pi, fine. If you put it the decimal value, go to 3 or 4 decimal places.